which actually is a marketing term that describes a lot of technologies that have been people have been working on for quite some time, involving connecting devices together that have some degree of intelligence, for instance, sensors and various sorts of things. The actual applications for for what we now call the Internet of Things includes a lot of industrial uses, includes agricultural uses, but also, in particular for this conference, includes things that consumers can use within their own homes or around their homes, or even within their clothes or other devices as well. So it's basically devices with processing capability, maybe some memory built into it, and a way to communicate with each other. And these often would be using, say, Wi-Fi or some other technology. Increasingly important is as we're, and a lot of this is driven by the fact that the total cost of making small devices, the electronics got more powerful, they're less expensive, we can put a lot of capability into a small thing. We've got better ways of managing radios and the power from radios, that sort of thing. And all these have enabled very low cost, which basically is driving the possibility, the very real possibility, that everything in our lives could be connected and smart. And so that has interesting implications. It also has new requirements in terms of the infrastructure to support it. So we start off, of course, with what can the endpoints do? For instance, your phone or some other device that is the connected thing. But also at the edge of networks. And there's developments such as 5G that you've heard about here that would provide, or other types of higher performance wireless networks that will be an important element in terms of connecting these things. But also, you can only build so much processing power into a device like this. And of course, you can't share until you get connected. So doing things at the edge, and even including almost, for instance, there's people designing what effectively are little data centers in a box that would go into cell towers and provide processing and other types of storage and other types of capabilities that allow devices to work with each other to create infrastructure for smart cities, for example. Cars communicate with each other with basically monitoring traffic, things of that sort. And so we have capabilities at the endpoints, devices themselves, at the edge of devices, and in the case of your home, maybe it's a gateway as well. You've got something that interfaces with most of your smart connected devices, and then that interfaces with the outside world. And then and those are particularly important, either processing, say in your car or at the endpoint, or close by when you've got something where you need to make a decision right now, because most of the data that's being generated has value now, and of itself it won't be kept long term. So results be kept long term, and if you need to do some bigger data or a bigger aggregation, then you go through the cloud at large data centers somewhere. So if everything we've got is smart and connected and talks about us all the time, do we have any privacy anymore? Right? And what can we do to ensure, even though we've created something which could provide enormous services, can it also protect our privacy? Can it help to keep us from being manipulated by other people or having things stolen from us? So that's an important element. Also gets into the whole security of these devices. How easily can they be hacked? They be taken over by other people, and at worst, be able to cause physical injury or even death potentially. And then there's we're monitoring not only ourselves, but this gets into some of the ethics issues we were talking about in the keynote here, is inadvertently or not, we're going to be picking up things about other people as well. What is going to be the implied social contract in terms of our interaction with each other, when it's not just ourselves interacting with each other, it's all our devices, which may be recording things and using it. So we need to develop new social norms and new ways in which we work with these things. Another very important thing, particularly for things like this or these watches, right? The battery only lasts so long. Power is a real issue especially for endpoint devices. You know, what can they do and how long can they do it? So building architectures and infrastructure, especially for the edge and for endpoints, that can operate on very low or no power, or for instance, if you're in an agricultural situation, can be something out in the field that's just got a solar cell and a radio, or corn powered, right? And making sure that these things will have a good power budget. So that may require changes in terms of the computing technology we use. Also, and this is an area, I'm a storage and memory guy, so moving from volatile to non-volatile memory potentially in some of these applications, since many times for instance, DRAM refreshing takes about half the power of a modern server. So, so power will be an important thing. There's going to be a lot of elements that go into that power, as well as building up better power sources, batteries, and also energy harvesting of various sorts. And then when we do get into issues, some kind of remediation of issues. You know, this also ties in some of those ethical issues. And we'd like it to be done by people that actually know a little bit about the technology. So this is where we get into something called public policy, which is people that are knowledgeable like us, you know, that are involved in various elements of this technology. You need to make sure that our legislators know how things work, so they can make intelligently designed laws and not things that are going to restrict us, you know, unfairly, and that actually will have positive rather than negative consequences. So developing ideas and sharing them with people who develop public policy and helping to develop that public policy may be an important part of that. And one of the important elements of that, of course, is standards. And this is standards both for the technical requirements, but also, and again, this keys into that keynote we just had from TELUS, also into, if you will, kind of the ethical requirements and what's going to be the social contract with the way these devices work with each other. Then we get into the whole thing about the industry and you know, the way we work with each other. What are going to be barriers to entry? What is going to be a fair competition in these areas? What should we look for in terms of you know, too much concentration of power, not enough competitiveness? These are all things that need to be looked at. And but also, you don't want to discourage the real possibilities of very great advances that could be made, and which could provide great value to all of us, but also generate real fortunes for those who create the startups, the companies, the technologies that become a very wide place.